Okay, so we're back. We're going to be doing lab 102. So that is this one right here. I do have two different layouts of it. One where you could copy over from the last lab, but I'm going to recommend that you build this one out. There's not a lot to it. It is available if you'd like to copy it, but I'm going to run through building it for you real quick. I'll let you watch. We'll speed it up. I'll touch on a couple of points to pay attention to. And when we are through it a little ways, I'll get back to you. While these aren't strictly necessary right now, I am putting them on here because in the future you'll want to make sure that you bring power to both sides of the rails. And that's not true for every project, because some projects you may have, you know, 3.3 volts over here and 5 volts on this rail, or 12 volts on this rail and 5 volts on this rail. But by and large, when we're dealing, we're gonna most of the time use the 5 volts on both sides, and you may need to jump over here. It may be easier to pull power from over here, or you may actually have devices that wind up over here. So we're going to move on. Okay, we got terminal 1A and terminal 2A. So this is our normally open, so it'll become closed when we press the button. So we got to rotate this guy. Pay close attention to that. You may wind up, if you mess that one up, it could be disastrous. I'll come over here from the 10. Remember, this is our signal wire, and we got our 10k ohm resistor here. That's our pull down resistor, so that's making sure that this pin here is always at 0 unless this button is actually being pressed. And then we'll pull our power into it right there. And pink they are. We use pink for signal. That's what we're going to use. Because why not? Make this a little pretty. So everybody sees where everything is going. Okay, there we go. I think we got this set up. So let's pop back over into our lab here. Got all our connections made. Looking good. So we're going to go over into our coding. So the setup's the same. Make sure all of our blocks are configured. I'm going to go ahead and select all. Okay. We got our loop forever. Now here's where we get a little different. We do need our output. So we need our 3 outs. We're going to write the digital pin high. Control C to duplicate that. Control V to paste it. We're just going to go something simple to begin with. And we're on pins 4, pin 5, and pin 6. And we want those all high. But before we get too far into this, we need to start looking at our switches again. We have a switch now. So we're going to use an if statement. We use if statements and comparisons. So if something equals something, then we can run our code. So let's go look for these. They're going to be here in logic. If we're going to need the comparison to equal, and we're going to go ahead and pop this in here. And what do we want to look at to equal what? So in our diagram here, what we want is for pin 10 to equal high or a positive. The digital pins are, for the most part, could be thought of as on or off, ones and zeros, unlike the analog. So we want pin 10. We're going to look for an input. We're looking for the digital pin, the logic state of digital pin 10. And then we want that to equal something. Now, there's a lot of ways that we can do this. The easiest way to do this is for it to equal the pin high. Just like we turn the digital pins high when we want them on, when the digital pin equals high, we know that it's on. So go to in, we grab our high statement, and this should work. There's our code. Let's copy it. Let's bring it over into here. Code. We want just text. We're going to Control A, Control V to paste over it. Close out the code. Start the code. And let's push a button. And they came on. And you notice I let go of the button and they stayed on. That's because we didn't tell it anywhere to turn them off. We just said, when you press this button and this pin goes high, turn on these LEDs. And just keep looping those LEDs in that on state. I want to also show you something here, because we're going to be using times. And I haven't quite figured out why this is. It's been 2 days now that I've been waiting, hoping this would improve, and it hasn't. But this is our seconds right here. So we're running far below what a normal second would be. And I've tried this on multiple browsers, multiple computers with the same results. Sometimes it seems to do better than others, but mainly what we need to watch out for is we're going to be using half-second flashes, and they may seem to take a lot longer than a half second. But what we got to look is, what is our milliseconds doing? How long are our seconds actually in this simulation? So let's pop back into the code. And so now we want to turn these off, right? And since we're kind of following along with this, and this is what you have at home, let's see what we're going to do to turn these off. So we're just going to add some delays in here to turn them off. So we're basically going to allow them to flash. And so what would happen in here is if we flashed it and then flashed it off, if we flashed it on, waited a second, turned it off, waited a second, turned it back on, if we press the button, it's going to run through this, but when it gets to this off state, it's just going to stay off. So let's go ahead and take a look at that. So we're going to make this easy on ourselves. We're going to hold it, Control C, Control V. That'll copy the whole group of them. And we're going to set these to low. We're going to need a time. We're going to use milliseconds. And to really make the flashing prominent, we're going to drop this down to 1/4 of a second. And that's mostly because of TinkerCad is running a wee bit slow today, so we're going to go ahead and drop that down to 1/4 second. So there's our code. We're going to write them high, wait, write them low. Copy. Look at our code. Control A, Control V. Let's get this out of the way. Let's get our code started. There we go. We can see we're running real slow. We're just now reaching 1 second. So here we go. So there's our flashing lights. And like I said, I put these down at 1/4 second. So we'd stop that. We could look at the code. Let's adjust it up to a half a second. See how that looks on here. Let's start the code, and there we go. Okay, so something else we can do is we can switch this out, right? This is a button, it switches. So let's see what else we could put in here. And this is in the lab here. I'll come back. We're gonna pull out this PIR, it's a motion sensor. All the electronics are included. All the electronics are included in this PIR sensor. As long as we give it power and a ground, it will give us an on-off signal when it detects motion. So just like this button down here, we can use this motion sensor as a button. So let's go ahead and rotate it into place. Okay, so what we did here is, since we already had our pull down resistor in here, and this is going back to here, we just jumped it across the breadboard to this side, and this is our signal. So it'll follow this wire over to this side, pull down, signal. we need to update our code a little here. Let's go back into our code. We're going to need a couple extra pins. So Control C, Control V, Control V. We'll get two more high pins, and those are going to be 7 and 8. Control C, Control V, Control V. Again, 7 and 8. And let's go ahead and copy that. And you see right here, every time we add one of these digital pins, it goes ahead and assigns it. We know because we pulled it from the out, and we assigned a digital pin, and when we fill that digital pin in as an output, it goes ahead and puts it in our setup up here. So that's kind of nice. It kind of takes care of that for us. Let's go to code, Control A, Control V. So we're not really changing anything as far as the code goes. We just added a couple of LEDs. But really, this is the star of the show now. So we'll go ahead and hit Start Simulation. We're going to go ahead and cause that. And then if we move anywhere inside here, they start blinking when it detects the motion. So this is like a very rudimentary motion alarm circuit. So there's our flashing. Okay. Let's see what was next. Okay, we're going to start talking about else statements here. So we want one of these lights to stay on when there is no motion. So that would be maybe say this blue LED, which is on pin 8. Maybe we want that one to be on, like the system is armed and ready. And these guys flash when there is motion. And so that's where these else statements come in. If we look at the full code here, make sure that all of these I don't know if we're going to be able to use these values because 2 seconds is a long time to flash with it's a long time to flash with how slow this is running, the 2 seconds here. So we'll probably drop this down to maybe a half a second, then maybe we'll keep these all at half a second also. And so what you can see up here, when we look in the code, when we pull out this else statement, we're going to do, we're just going to grab it from down here and add it to the if. And you can see where it clicked it on down here. So what this is saying is, if this, do this, else do this. So we want pin 8 now to be on. When everything else is off. So we're going to go ahead and put pin 8 in there. We need to pull pin 8 out from here because we no longer need it. And we're going to put that guy back in there. Now what we do need to do though is we want pin 8 to go off when this pin goes high. So we're going to go ahead and add that right up here. And that's going to, what that'll do is it'll turn off this. And to kind of make a point of that, we'll not put it in this first one. So right now we have, let's make it loop a couple more times. All these together because we want this whole thing to loop again. So we're going to go Control C, Control V, and there we go. Now we've got the full looping effect. And now this obviously is. This is a long way to do this. We'll talk about ways to shorten this up later. But right now, we just want to see what it looks like and see if we get the desired effect. So we're going to copy our code. We're going to head back over here to our circuit. Control A, Control V. Move the code out of the way. Start our circuit. And our blue light's on, the system is armed, and there's movement. See how the blue light didn't go out. And that's what I was talking about. That's why we need to tell it to turn off. So we're going to Control-C, Control-V. So we got one of these. We're going to put it up here at the very tippy top. And this is going to turn that blue light off when all of this starts. So we can copy it. Let's try that again. And basically what we changed here, Control-A, Control-V, you see we didn't change a whole lot. All we did was digital write to pin 8 as a low. We didn't change a lot at all. But it's going to make all the difference in the world for how this works, because we got our blue light on and the blue light's off. It's detecting motion. And once the system resets, we're back secure. And that is our makeshift motion detector alarm. So in the next one, we're going to start working with analog inputs. Analog inputs are a little bit different than the digital. They're more than just on-off. We can actually read a value. And so with certain sensors, maybe say temperature sensors, certain types of temperature sensors, certain types of distance sensors, depending on how the sensor is, we can use it as an analog value. We can read it as a value. So we can have, we're going to use a potentiometer actually so we can adjust it and watch. But this is it for now. I hope you guys enjoyed it. Play around with this, break it, fix it, and have fun.